Hi all. Today I learned the feature selection and the two algorithms. One is select k-best algorithm and the RFE recursive feature elimination algorithm. So I'm going to explain this. So in the select k-best algorithm for classification, we have to input the required libraries, and then feature selection we have to import the select k-best algorithm and the chi2. So actually chi2 is actually the chi square, so which is in a method, which is a score function. So what it will do is, so it will actually finds a relationship between the independent categorical independent variables and the categorical target variables. So it will actually compute and the score between the two variables. So it says how much related the independent variable to that particular target variable. So it will check the one by one features, and it will try different combinations according to the k value which will give. So this is how the select k best algorithm will work. So here I have given the select k best algorithm with the score function chi square, and it is for classification. If you go for the regression, we have another score functions like r regression, we have to give that. Then we are actually fitting the model with input and output, independent x and independent y, so which actually learns the important features, and the transform selects the important features. So this is a functions, and another function is for just splitting the time and test and standardizing the data using the standard scalar. Then as it is a classification, we'll actually use the confusion matrix and the classification report in order to evaluate the model. So here I made the like predicting the y and the confusion matrix and the classification report. So it will calculate based on the actual was predicted. So based on that, we'll get the accuracy score and all the reports, so that I'm returning here. Then we are actually separately. Okay, so here the logistic regression algorithm, I have tried the many classification algorithms. So for each classification algorithm, I have developed the functions. So in logistic regression, importing the libraries and calling the logistic regression functions, and fitting the model and calling the which is a CM predict evaluation function. So where we predict the y and also calculate evaluate the model using confusion matrix in the classification report. So the result will be stored here, and also we are returning the same here. So which this will be the same process which will be applied for all the algorithms. So using knn, so knn we have to pass the mean parameters, which is k neighbors, p equal to 2 Euclidean distance, and metric and Minkowski. And they for svm we have 2 for linear, and for non-linear we have separate things. So for linear the kernel will be linear, for non-linear kernel will be rbf. We have other kernels as well, like poly, sigmoid, pre-computed, etc. We can choose according to the use case. And the navy bias, in navy bias I'm actually implementing Gaussian navy bias and decision tree and random forest with their specific parameters. So then next the final table, so which this will be including the accuracies of all the models for that each features which we have computed. So I'm just putting the index of chi square and the columns for algorithms which we have trained and which we needed. So it is actually looping with the index, so that I will easy to access the each algorithm, and I will be assigning the accuracy of that particular respective algorithms here. So this is up to this is all about the function definitions. So next is the main program. So I will load the data set, and I will convert the categorical to numerical, then separating the input and output. And here I will be giving the number of features, how many features I have to consider, and I will be calling the select k-best algorithm here. Then next here I'm just plotted to see which are the features I'm getting from the model. So for that you can use the fit one, which is the selector of the model select k best and get support function to see which are the features the model was selected when we are giving the feature numbers. So here I have just commented it out for each features 5, 4, 3, whatever the features my model was considered. So after that, here I will be calling the original function, so trust range split and all the separate algorithm functions. And finally I will be calling the select k classification table. So here I will be getting the table which I computed for each algorithm and the chi-square. Okay, so for each feature, five features, this is the table 4 and 3. So after comparing all this, so what I got is, so the three features model as the model accuracy which is lower. So 5 to 6 features are actually given the accuracy which is actually moderate and more generalized. It is not overfitting. So 10 is actually decision tree is 100%, but it might be indicating the overfitting, so we have to choose the generalized model. So I'm going with, we can say like the six features and the five features have the most good performing accuracy, and also it is more generalized one to go with the five and six features. So then I have tried the same for regression. For regressions everything is same, so the evaluation metric will be different. We will be using r square, so y prediction and the r squared score for evaluating the actual predictor. So other than that, standardization test train split is same, and the algorithm for regression is linear uh, and SVR and decision tree random forest. So I have defined each algorithm, then the same table for this. So this is the main function for that particular regression. So as this is I have imported the same classification problem, it will act usually that for classification problem regression ought to work. So it gave the poor accuracies. So that is the reason here. So we can try with the regression problem by using this code. Okay. So next is RFE. Okay. So next RFE, which is recursive feature eliminations. So in select K algorithm using the chi-square method, it actually compared each feature one by one with the target feature. But here it will actually compute with the model, which is machine learning algorithms. And it will identify the most important features, and other than the that all the features one by one the features will be eliminated, so it will only consider the important features. So other than that, it will eliminate the unimportant features one by one. Okay, so that is how the RFE works. So I am importing the libraries required for that. Then here as I said, we will be using the machine learning models for um, in the RFE feature selection. So here in the RFE features for classification, I have created the function, and I have mm, made the logistic regression and decision to classifier random forest classifier algorithms here, and I have made into an one list. So after that, for each model, I have come calculating the RFE and selecting the features for that each model. Okay, so it will be like for logistic regression model. So based on that, it will train the data and it will get the particular number of features best for the data set according to the pattern which is learned using the logistic regression. So same applies to the next two algorithms. So after this, the same fitting and transform for selecting the important features. Okay, so here I will return the list which will be the result list which has the features. Okay, so features returned by these three algorithms. So either it will be returned based on the values, how many number of features we will be giving. So if we give five features, then using the log model, it will give five features, and using the DT decision tree model, it will give five features, and the random forest it will give five features. Okay, so and the split scalar, which is test train split and standardization. So this is all are same, and evaluation metric, confusion matrix, and classification report on all the classification algorithms. So this is all are same as I mentioned in the select K algorithms. Okay, but here the table will be different. So that I will explain after the main program. Before that, I just wanted to explain how this particular thing will look. Okay, so how each model has the different features. So here I have run the code. So here we can see for logistic regression, when given the five features, so it has selected AL, SC, and RBC normal, RBC unknown, and PC unknown, and HTS. So these are the five important features for logistic regression. And for decision tree it has different features, and for random forest it has different features. So based on the model pattern recognitions for the data set, it has predicted the different features. So based on this, we will be creating the model for each algorithms. Okay, and we will actually predicting the accuracies. So the log model has these particular features. So this particular features will be considered while creating this model, and these accuracies are for that. Okay, for that particular features. So, and for decision tree model, it has these particular features. For this, we will be creating the models, and then these are the accuracies respectively, which we get for that particular features. So this is how it will work. And here the main program, loading the data set and converting categorical to numerical and splitting input output. And here I'm giving the number of features and calling that particular functions. Okay, so then while we are calling the other functions, so we will be noting the accuracy, but here we will note in the dictionary format, and will actually store the dictionary into a list. So we will be calling this function, the table creation functions, with the list of dictionaries, because here I need it as a 2D array, which will be like for log model, it will be having each model creations, and for DT model, which is decision tree, also each model creation. So it will be like a 2D array. So for each row, I have to call each models and have to compute, so that I will be sending as a list of dictionary. So this list of dictionary will be converted into data frame, and here it is plotting as the 2D array, so which will be easy for us to analyze. So here I have analyzed for different features from 3 to 7. So from this analysis, I can say that for the decision tree and the random forest is consistently given the 100% results in most of the features. Okay, so it can be because of the data set is highly separable, or it is overfitting. And by my analysis, I have seen a significant um, I didn't see any significant improvement under the 3 4. Okay, so here for the most of all the features, it is actually performing well. And with the minimum 3 and 4 features, also the model is actually performing well. It is very slight difference. So we can actually conclude as the 3 and 4 features is actually the optimal models, and we can take like from this itself based on the accuracies, the random forest is performing well, and the decision tree. Okay, so based on the features we can finalize it. So I've also tried for regression. So regressions all are the same. So for here we will be trying with the regression algorithms, and passing the estimators as regression and just creating the list for that. So similar to that, a classification, but instead of the classification algorithm, we will be training with the regression algorithm. Okay. So in this, some of the SVR algorithm, we will be getting errors because it doesn't have the coefficient. So in that particular time, we can go with the other algorithms. So or you can, if you want SVR, you can use linear SVR. So that will be good options. So then the R square evaluation metric for regression and the regression algorithms, the same kind of table. And this is the main program for that. And these are the analysis. So in this analysis, I have computed for 3 to 6 features. In this 3 to 6 features, um, the third features and the fourth features, is model is not performing that well. And the sixth features, a model nearly achieved the perfect performance. Okay, uh, so five is more generalized one, but also it is actually the classification problem. I just experimented with the regression one. So So the same process we can do for the regression problem, so it works well. Thank you.